Let's look at an example of a somewhat real world situation. We've got a bunch of data, so this is a tabularly defined scenario, which may or may not be a function. In our questions, we have two questions actually. Is c a function of y, and is y a function of c? So let's start with this one. Is c a function of y? Well, remember the sentence, blank is a function of blank. So this means output, input. Okay, so going up here, whoops. In this question, y column 1 is going to be our input, and c column 2 is going to be the output. So does it work to have these be our inputs and these be our outputs? So remember, what we have to have is that we cannot have one input going to more than one output. So basically you can't have 2001 go here and here, right? If it did, then that would be bad. That would not be a function. But that is not what we have. So we only have 2001 going to one value, and 2002 goes to one value, and so on and so forth. So yes, this is a function. Well, that's a really bad yes, but I was trying to write yes down there. Okay. So yes, it is. Now, what about question 2? Well, let's go to a different color. Okay. All right. Is y a function of c? Okay, so basically we're gonna turn things around now, and we're gonna say y is going to be the input. I'm sorry, the output, and c will be the input. So we're going to try to go this way. But we have a problem, because look right here. We have 2.1 going to two different values. So that's equivalent to saying this, to having that right there. And that is not okay. So no, not a function. This is a funny pen that I'm using. But so this is not a function. Okay. These next slides actually take this data and put it into a stat table, and then graph it as a scatter plot. So we've already verified that it passes, that it's a function. So if it's a function, then it will pass the vertical line test. So we don't actually have to check that, but here I've actually checked it in case you want to do so. Okay, but in the other direction, y is not a function of c. Okay, and if you were to graph this in a scatter plot, then using the same methods that we did before, you would see right here that you got a problem. Okay, so not a function. All right, let's look at another example. So this is our first graphically defined function. You know, we're looking at a graph. Not only though is it defined graphically, it's also defined in words. So let's read those words. For a, oops, sorry, I dropped my pen. For a typical American car, the fuel economy M in miles per gallon is a function. All right, let's go back to a normal pen here. A function of its speed S in miles per hour. Okay, so miles per gallon is a function of speed in miles per hour. Or I guess fuel economy is a function of speed. So fuel economy is going to be the output, and speed is the input. So speed is input, fuel economy is output. All right. So what does our function look like? Well, as we speed up, as we press the accelerator and go faster, right, our fuel economy goes up for a while. So actually, it's more fuel efficient to drive at, say, 40 miles per hour than it is to drive at 10 miles per hour. But that's only true for a while, because once you exceed a certain speed, which is about the speed limit, right? Or, you know, the most common speed limit you see, 55 miles an hour. Once you exceed that speed, then your fuel economy actually starts to decrease. Okay, so there's sort of a domain in which you're maximizing your fuel economy with certain speeds. Okay, so what is the fuel economy for a car traveling at 10 miles per hour? So 10 miles per hour is an input, so here's our input. And my fuel economy, it looks like it's about right there. So let's say it's like 16, approximately 16 mpg. Okay. Now, question B, for what speeds is a car's fuel economy 25 miles per gallon? This is one of our turnaround questions. So we are given the output and asked for an input. So if the output is 25, notice what I'm doing. I'm drawing a horizontal line and looking for my intersection. And then actually, I need to keep going because I have another point over here. And so those 2 points right there, I should probably use a different color. Maybe I'll switch to this guy. Let's see what color that is. That and that. Oh, it's a dotted line. Isn't that nice? Okay. So, but what we need to see is what they correspond to in the horizontal axis. So this is going to be an approximation, but I think it's about 20. And I think this one is about 70. So I'm going to say 20 and 70. Again, I'm only approximating here, so and here's my slide answer, 20 and 68. Okay. And 16 miles per gallon for the first one. Okay. Just a brief note, if you're thinking about domain and range, going back to this picture, notice that our domain stops right here at like 75, right? And so if we restrict our domain to be 5 to 75, then our range would be from here to whatever that high point is, which looks to be at 30. So let's say 11 to 30 or something like that. And that would be our range. Okay. Here's a note about finding domain and range values graphically. I encourage you to read this. I'm going to skip it though. Okay, so we'll pause here, and when we come back, we will begin section 2.2, describing the behavior of functions.